Hello, my dear viewers. How are you for doing? I know everybody is fine. So today we are going to get the next segment of gas laws. Last time I only stated the gas laws. We said we have things like Boyle's law, Charles law, pressure law, general gas law, Dalton's law of combining volume, Graham's law of diffusion, Avogadro's law, and so on and so forth. So today we're going to be looking at Boyle's law. Yes, what we need to know about Boyle's law, the first thing is the definition. Yes, and Boyle's law states that the volume of a fixed mass of gas is inversely proportional to its pressure, provided temperature is kept constant. So from here, you notice mathematically, so Boyle's law, so actually it states that the volume of a fixed mass of gas, the volume of a fixed mass of gas is inversely proportional to its pressure, provided temperature is kept constant. So that's Boyle's law. Then we can still state it mathematically. So mathematically, V is inversely proportional to P. That means as pressure will be increasing, volume will be reducing, provided temperature is kept constant. But in Boyle's law, two things are kept constant: temperature and the fixed mass of gas. The mass of gas cannot be altered, it must be fixed before this inverse relationship can hold. So now from here, which means V will be equals to, whenever we remove the proportional sign, then a K will come in. That K is called the constant of proportionality all over P. You can cross multiply. This is a fraction. So we can take this times this will give me PV equals to what? K. So which means the product of pressure and volume is always a constant. So this will give us P1V1 equals to P2V2. So this is the formula that we are going to be using to solve the question. So then from here, we will now take a look at the representation of Boyle's law. Our representation of Boyle's law, we can get the representation in this format. This is V1, V2, V3. Then the pressure is P1, P2, P3, showing that as the volume is decreasing, the pressure is going to be increasing. Then we also have its graphical representation. The graphical representation, we can plot a graph of volume against pressure. The graph of volume against pressure is going to be a curve, showing that when the volume is maximum, the pressure is going to be minimum. Yes, and when the pressure also is maximum, the volume is going to be minimum. Or this other graph can still be accepted. A graph of V against 1 over P. So then the graph of V against 1 over P. So the inverse nature has been taken care of in the horizontal axis. So that graph will be a straight line. So being a straight line doesn't mean it is not an inverse relationship, because if I have a value here, like for example 4, that 4 is not equals to P. That 4 will be 1 over P. And if you have 4 equals to 1 over P, then you make P the subject. This guy will go here and this one will come here. So P will be 1 over 4, showing that it's still an inverse nature. So this graph is being accepted, and this graph is also being accepted. In our next video, we are now going to be looking at examples that has to do with Boyle's law. Thanks for watching my video. Do like, subscribe, and share. Bye.